So the first talk I'm going to talk about is about schemaless data structures. It's a fashionable thing to talk about at the moment because if you've at all looked at NoSQL databases, one of the things that's common to pretty much all of the NoSQL databases is that they talk about the fact that they're wonderfully schemaless and all the fantastic things you can have with a schemaless database. But when a lot of people talk about schemalessness, I think they miss out a lot of the subtleties that you need to understand to really understand whether it's a good idea to be schemaless and also how to use it effectively. So that's what my first of the talks is going to talk about. I'm going to talk a little bit about this. And I'm going to divide it into two parts. First I'm going to talk about what schemalessness is. And then in the second part, I will talk about when you might want to use it. And I'm going to move around the stage a lot as I talk, partly because I normally do that, and partly because it really makes life hard for the cameraman, so he's got to spend a lot of time trying to catch up with me. So to begin thinking about schemalessness, let's think about what we typically imagine in a relational database schema. So we typically expect when we create a table, we define the columns for that table. We say what they are, we give them each a particular name, and we give some indication of what type they are. And then at some point, should we wish to insert data into that table, we have to follow that schema. And if we try to insert something that isn't defined in the schema, then we'll actually be prevented from putting the data in there. Now with a schemaless database, which is a typical NoSQL database, of course we can store whatever we like in there. We can have records of people with different fields and different capabilities. And that is the thing that you hear most people talk about when they talk about the great thing about schemalessness in NoSQL databases. They'll say, it's really good because you don't have to fit yourself to the rigid structure of the relational database. Instead, what you can do is store whatever it is you need to have in whatever form it happens to come. But there are disadvantages to being schemaless. Let's imagine we're storing some data in a database and we just want to find certain parts of the data with a nice simple query. And with that query, that will allow us to find the records that we're interested in. Unless, of course, one of those records is effectively what we should be looking for, but there is some difference in its schema. So in this case, obviously I'm using an American zip code idea, but I mean, what do you call that field? Do you call it zip? Do you call it zip code? Do you call it postcode? How do you know which to match to? And what this leads you, I think, to the way to think about this is saying that the data may not have an explicit schema that says how you might want to store it, but there's always an implicit schema. You are making an assumption. Whether do we use the word zip for the zip code? Do we use zip code for the zip code? Or do we use both? That is in there in the data, but it's all implicit. It's not an explicit thing. And the implicit schema is effectively defined by all the code that accesses that database. All the code that reads from it, all the code that writes to it. That's where the implicit schema is there. And just because you're using a schemaless database doesn't truly mean you are schemaless. It just means that your schema is purely an implicit one. Now I've talked about this in the context of databases because that's where the chatter is most at the moment in terms of schemalessness. But in fact the same ideas apply to in-memory programming as well. Let's look at an example in a couple of well-known programming languages. And what you see is we can define certain classes of objects and define what fields are present on that class. That is effectively a schema. And it doesn't have to be just in an object-oriented setting. Old-fashioned C has the same thing with structs. Anytime you're defining your record types, you are defining what you have with a schema. And similarly, in an in-memory language, you can also go schemaless. And you go schemaless, typically by using some kind of dictionary, hash map, associative array, something of that kind. And most languages have this as a built-in data type or as easily available through standard libraries. And that allows you that same degree of flexibility. You can store whatever values in the map. You don't have to predefine them by predefining the fields in the classes or structs. But the question then is, well, what's the advantage of doing one or the other? Is it really a matter of the difference between saying dot something as opposed to putting something in whatever the property access is? Where is the trade-off here? Now, in general, my feeling is that if you're going to use a field explicitly, you really want to have a defined field. Again, it's this explicit schema thing. If you're using a dictionary and you're putting data into it, you've got the same kind of implicit schema that I mentioned in the database case earlier on. How do I know what I'm going to use for the first name? I've got to decide on what my keys are that I'm putting into that dictionary. And where do I find them out? If I'm going to probe around the code to find whether I'm using first name or Christian name, where do I find this? Well, I've got to hunt around in the code if I've got an implicit schema. But if I've got a defined class with clearly defined fields, then it's easy to see what I'm using for the different things. Now, where a dictionary really comes in useful is when you're not actually explicitly typing in the field name with a literal value, but you're pulling it in from some other source. Maybe you've got a display of fields on the user interface where you are treating them as a purely dynamic thing, and you've got property name, property value, something of that kind. In that situation, that's where having the kind of implicit lookup is quite useful. On the whole, my view is that if you're using something like a map or a dictionary and you're typing in literal values for the keys, that's a bad smell. That's an indication that you should be instead thinking about having defined fields, because it's easier to see what's going on that way. Now, just because you're using looked up properties doesn't necessarily mean you have to use a hash map. You can, most languages will give you some kind of reflection capability, which you can use to get hold of that as well. So there's definitely a choice between the two. And sometimes you might find that there are advantages one way or the other, various things that you've got to trade off. Now, this is actually a very old trade-off. Back many years ago, Kent Beck wrote the book Smalltalk Best Practice Patterns, and he coined this as a difference between what he called common state, which is when you have the defined fields, and variable state, where you use something like a dictionary. And what he pointed out is that the variable state is useful when different instances have different things that need to be stored about themselves. And then it's useful to have them in this variable state with a hash map. But when you've got most of the instances having the same things, then it's better to define them clearly with fields. And this isn't an either-or choice. You can combine both techniques in the same class. So in this example here, I can have defined fields for the first name and the last name, but also include a hash map in the class for any other values that I might want to stick in. So this allows me effectively to use both patterns at the same time. Now, just because I'm using both patterns, I don't actually have to use explicit fields for the storage. With this example here, what I'm doing is saying I've got a single customer class that's got an interface that looks like it uses explicit fields, but it actually stores all these in an underlying hash map. Now, this can be quite a useful technique, particularly these days where we're seeing a lot of people store data in things like NoSQL databases in, say, a JSON format, and then pull it out to a user interface, through a service interface in JSON, or through single-page applications that take JSON. If you're going to do that, you might as well store the data in your objects that you might want to manipulate as JSON as well, or deserialize them into a dictionary, because that kind of stuff is easily built in. The crucial thing to remember about objects is that the interface and the implementation can be two different things. The point of encapsulation is to hide what your actual data representation is. And as a result, using a dictionary internally, but exposing something that looks like defined fields from the outside is a perfectly reasonable way to go. That way you've got an explicit schema of your defined fields, but at the same time you don't have to be always having an awkward copy into different data structures as you're flowing data through the application. So here we see that in in-memory programming we can combine the notions of the explicit schema and the schemalessness. But you can do the same thing even in a traditional relational database. And in fact, we see this all the time. There are 3 common patterns to how this is done. The first one is to use effectively custom columns that don't really have a name, but they're used by convention within a program. Another technique is to actually have a custom data field which you then fill with some kind of structure that allows you to put the variable state in there. So it may be JSON data embedded within a string field or something of that kind. This second technique is the closest one to the in-memory technique that I showed earlier on. And then the third approach is to use some kind of associative lookup table that allows you to add custom fields to tables. You've probably all seen this technique if you've ever dealt with any largish relational database application, because there's always a need to put this stuff in. And, to be quite honest, it is all 3 are rather clunky mechanisms. This is where, if you find yourself having to do this a lot, you begin to feel the need for some kind of schemaless approach instead. But this is really just a way of kind of hacking schemalessness into the relatively inflexible and fairly rigid relational structures. So, covering what I've made so far, we can do schemas and schemalessness both in databases and in memory. And it's not necessarily a 100% choice between one or the other. We can combine a fixed schema and a variable schema. But one thing that's been fairly true of what I've said so far is that we've seen the schema as what I think of as a storage schema. But what I mean by a storage schema is it says if I want to store some data in my store, whether it be an in-memory store or a database store, the schema will prevent me from storing something that doesn't fit. And that's how a relational schema operates. And it's effectively how defining classes and fields in a record structure or a class works in memory as well. You can't fit something in there that doesn't fit. But that's not the only way that we can use a schema. A less common way of using a schema, but also quite a useful way, is what I call a predicate schema. Now in a predicate schema, what you're doing is you're allowing anything to be stored in whatever your storage mechanism is, but the schema can be used to detect what shape of things it is. So that way, you can detect, have I got anything that doesn't fit the defined bounds that I'm putting in place? I might store something that says zip code, even though my schema says zip, and then as a separate step, I'll go through and say, does anything not fit the schema? Or perhaps when I read the data, I can first test to see if it fits the schema, and then if it does, I can make certain assumptions about how to deal with that data. Now, predicate schemas are relatively unusual, but one place where you may have run into them is something like XML. If you've got some kind of XML data, it's just text. You can store whatever you like in there. But there are various ways to test XML against the schema. Now the best known one for this, I guess these days, is XML Schema, perhaps because it's got schema in its name. But it's not a terribly good schema language. And the one I've shown up here is something called relaxed compact notation, which is a much nicer schema notation, but it's easier to read and understand. And this gives you a way to be able to then test an XML document and say, does it pass the schema? And this brings up an interesting point. That when you've got things like predicate schemas, you don't have to limit yourself to only one schema definition language for the kinds of schemas you're operating with. You can use different schema definition languages depending on different contexts and needs. What's more, you can actually separate the schema from the storage in order to be able to have different schemas for different circumstances. So here I've got kind of my basic appointment schema, but I can have another schema that says, let's take that basic one and extend it, because if I want to have a confirmed appointment, I need to actually define who the physician is as well as the patient information. And so this allows me to take the same data but have multiple schemas that I can test it at depending on where I am in the process that I'm working with. This is actually a very valuable thing because it introduces the notion of contextual validation. Now what I mean by that is that when people talk about whether they want to validate something, they often look at it as a purely binary thing. Some class or record or piece of data is valid or not. But that, although that works a lot of the time, it isn't really a very complete way of looking at things. Usually when you want to validate something, the validation rules will change according to the particular context you want. And the context is usually of something you want to do, some action you want to take. And so, validation rules, you may well have multiple different sets of validations for a particular thing. So, if I've got an appointment, I might have one validation that says, okay, the appointment is set up and ready to go, and different validation that says, okay, this is confirmed, and something that's actually going to go ahead. And the validation rules will subtly differ. In fact, what we're talking about with a storage schema is saying the context of this validation is that I'm allowed to put it in the database at all. And this is, I think, where a lot of people kind of go down an awkward route, is that they put very strong rules on this validation of storing something in the database. Often it's useful to have relatively weak rules for storing it, and then be able to follow up with validation checks later on to say, is it actually, I may have stored this, but is it actually something I can do something with? And what is that thing I want to do? If I'm storing an order information, is it enough information that I can actually ship the order? Is it enough information perhaps that I can demand payment and calculate a price for it? Or am I still unsure? People are often reluctant to store partial information and things of that kind. And that's because you confuse the rules for the validation step of storing with the validation steps for the actual actions you might want to take. So in fact, schemas, I hope that's given you a sense that there's a lot more to schemas than just the notion of what a relational schema might be. They're actually quite interesting and subtle things, and we could arguably use them a lot more widely in our programming anyway as a way of trying to describe rules for validation and things of that kind. But now I want to move on, having sort of talked about schemas, to when we might want to use a schemaless approach as opposed to actually defining a schema. So, to start with, I like to think to myself, what is the consequence of us going with something schemaless and saying that we've got the customer and we're just going to make it a hash map, we're not going to define a class or make any schema or anything of that kind. The question then comes in, and I've alluded to this quite a few times already, is what are the legal keys by which I can access that hash map? How do I find that out? Well, I've got to look through the code and I've got to find out where are all the places in the code where I access that customer. And there could be a lot of code, but I've got to hunt around to try and find those spots. So my general advice, as a kind of first approximation, is to say, don't go with implicit schemas. Because if you've got an implicit schema, you've got to furk around all over the place to try and find out what the legal values are. Have some form of explicit schema if you can. That may be some defined storage schema, or it may be some way of testing against a predicate. But have some place that people can go to and say, okay, what do I call this? What do I look for the zip code? Do I call it zip, or do I call it zip code? Make that as explicit as you can. And it is certainly a common theme that I've run into where I've talked to projects that have used schemaless solutions where they say, yeah, it all worked really well for a while, and then we started having great difficulty trying to find out what was actually being stored in the database. An explicit schema can help deal with that. But that's just the first point. There are cases where having a schemaless approach can be valuable, and it overrides the general advantage of an explicit schema. And I'm going to boil this down into this bunch of cases here. The first category of cases is cases where the data you're actually storing isn't uniform. If most of your data has the same fields, then it's easy to see what to do with an explicit schema. But if you get variant information from instance to instance, then having a fixed schema is just too hard. You've got to come up with some kind of flexibility mechanism, and the relational one, as we saw, is particularly ugly. There's two main situations where you get this kind of non-uniform data. The first case is where you want people to be able to define custom fields. This is quite common in products, where different customers want to store different custom values, but you find it on various other situations as well. Whenever you have this kind of custom field, that's a situation where you may want to use some kind of schemaless approach, at least for that custom field's part of it. And this is again where it can be very useful to find a way to combine both a fixed and a variable state. The other situation is where you've got different types that are very variant in their own case. A great example of this is if you're doing some kind of event logging, where each event type carries its own different kind of data, and they can vary quite enormously between the different kinds of events you have to log. In that situation, again, a more schemaless approach can be very handy. Now, the other main reason that I hear people talk about the benefits of going schemaless is when it comes to migration. As you want to change your data storage needs over time, if you've got a schemaless approach, this is great. If you change your data structure, you can just store that changed data structure and have old versions as well as new versions in your storage area. But I think this is actually a somewhat oversold advantage. Because the problem with schema migration is you've still got the implicit schemas, and what's worse, they're changing over time on you. Now, you can manage this to some degree. If you, for instance, just rename zip code to zip, you can actually have a reader that's able to look for either value, and then a writer that only writes out the new value. So you get some flexibility there. But as you get to more complicated migrations, you do reach the point at which you have to do a more formal migration step. And when it comes down to it, it's not necessarily a terribly complicated exercise. I've heard people say, well, the problem with fixed schema databases, such as relational databases, is that it's very hard to change a schema over time. Well, actually, that's not terribly true. Projects that we do at Forwards, we change our schemas all the time. We've had to, as part of an agile way of working. And what it requires is the disciplined practice of schema migration. What boils down to making sure that every time you change a schema, it's logged, tied in with a version control system, and you use lots of small migrations for every change that you make that migrate the data. And then you can change from one version of the database to another by composing the migrations together. I've glossed over the process, but you can find details of it in various places, but it's actually a very well-worn technique. And the same technique really has to be used for NoSQL schemaless databases as well. Eventually, all of those special hooks to deal with old versions of the data get too complicated, and it's better just to migrate the data and then only have a simpler mapping to the up-to-date structure. So you pretty much have to go through the same migration process with a schemaless database as you do with a fixed schema database. You get a bit more flexibility, you don't have to do it every time, but eventually you're going to have to pay that cost. And so as again, a common theme I hear from projects that have used schemaless databases is we still have to worry about migration. It doesn't go away as a problem. But on the whole, use an explicit schema as much as you can. Be very clear about what data you expect to store in structures. Use the implicit schemas really only in the places where you really need that ability to handle the non-uniform data. And that's the first part of the talk. If you want to review the stuff that I've gone through, in general, if you look at my talk notes, page on my website. I point to where my notes are, but I actually have an info deck version of this talk that you can read through that's got all the reading stuff there, not just me talking, so you've got a better feel for going through the material. And that's the first one. So for the second talk, I'm going to shift into a completely different mode. First one was kind of very programmy, hands-on-y, and this is going to be much more process-like and talk a bit more about Agile stuff. And this one is really very much influenced by a paper that appeared about a year ago about levels of Agile fluency. It's a paper that was written by Diana Larson and James Shaw, two people who've been involved in the Agile world for a great deal of time. And I first saw it when they sent it around various people just looking for comments. And I asked them, have you decided where you're going to publish this paper? And they said they hadn't, and I offered to put it on my site, and then they ended up publishing it through martinfowler.com. And I was very happy that they did that, because I think it was a very good way of thinking about how teams adopt and where teams want to be in the Agile adoption process. And I'm going to talk about that, but before I talk about that, I'm going to talk about what I see as the essence of what Agile software development is about. And I think it's important to talk about the essence, because it's something that easily gets lost in all of the Chinese whispers and stuff that's gone from 10 years plus of the Agile world. So to think about what Agile means, it's important to think about where it came from. The ideas that kind of coalesced into Agile software development appeared in the 1990s. And they were a result of a bunch of people relatively independently doing their own things and developing stuff. In the 90s, the general situation was projects are full of problems. Projects are full of problems now. We hope Agile has made things a little bit better, but these problems were certainly very apparent then as well. But at the time, there was a kind of expected idea of what the cure was for those problems. And that was what we think of now as the plan-driven processes. Capability maturity models, very much this idea of defined processes. We need to get rid of the human element. We need to define steps that people can just follow. We need to come up with plans and designs in advance. Programming is really just something we can kind of ship off to some minor organization, preferably in a poor country where we pay them less. And it was really seen in that kind of light. And that was sense that if we wanted to cure the problems of software development, that was the direction to go. But the people who were working in the Agile world said, no, we have a different vision. And it was a vision that was put together in the Agile Manifesto that said we have a different way of thinking. And when I sort of came across Agile methods in the late 90s, one of the things that struck me was how they all related with each other. And I ended up writing an article about this, which I called The New Methodology, because I wrote this before the Agile Manifesto came out, and it was my attempt to try and synthesize together the thinking that led to Agile. And the way I looked at it is that there was really a distinction between Agile and the plan-driven approaches and ways of thinking, and there were two main areas where they differed. The first was that the Agile world was adaptive in its approach to planning, while the plan-driven world was predictive. And the second was that the Agile world was very much oriented around people at the front, while the plan-driven world was around the process at the front. And I'll explore what I mean by those things in a little bit more detail, starting with the planning approach. In the plan-driven world, it was very much operated on the basis of first you plan your work, then you work your plan. Come up with a plan, and then carry that out. And the two were very much separated steps. And this is why I thought it was predictive planning, because the idea was that if all went well, everything goes according to plan. And in fact, the way in which plan-driven processes typically measured success was according to plan. Whenever you hear someone saying, we were on time and on budget on a project and therefore we succeeded, that's predictive planning thinking. That says success is we follow what went on in the plan. And this is all very well, but the problem is that the plans that people made had a very strong dependency on the fact that they understood what the requirements were. Hence even the word requirements. If you're going to come up with a plan for how you're going to do something, you need to know what it is you're trying to build. But the problem, of course, is not just does this tie your plan onto that, your entire software development process gets tied into it. And the problem then is, do we ever actually have stable requirements? I always like to do this. How many of you have been on a project recently where your requirements have been very unstable? They keep changing a lot. Yeah, nearly everybody in the room, right? And that's the kind of where this whole thing breaks down. So the plan-driven people said, okay, we've got to stabilize, we've got to get rid of this requirements churn. And we come up with all sorts of techniques about getting rid of that and stopping it. The Agile approach is to shift away from that and say, well, if software development is dependent upon requirement stability, and that's causing all of these problems, maybe what we need to do is break the dependency. And instead find a way to get rid of that link. So hence the subtext, the subtitle of Ken Beck's book on extreme programming was Embrace Change. Let's look at change as something that we can work with instead of something we have to prevent. And that shifting mindset is very fundamental to the whole thinking of Agile. And in fact, it even goes beyond that to my favourite quote of Mary Poppins. Let's actually take that change and see it as something good, something that gives us advantages because we can respond to that. And so as a result, if you're in an Agile environment, you can't claim success as going according to plan. And in fact, if anybody says, oh, it went project according to plan, that's really not at all Agile thinking. Agile thinking says success has to be defined something differently. You know, like we produced some useful value for the business or something of that kind. Whether it was according to plan or not is kind of irrelevant because the plan has changed 20 or 30 different times since you actually did the first version of the plan. The other notion that I rather liked was a project manager who said to me once that a plan is rather like a lettuce. It looks good on the day you got it. After a few days, it's looking rather wrinkly and crummy around the edges. And after a couple of weeks, it's unrecognizable. And that is, again, the kind of Agile thinking. Doesn't mean you don't plan, you plan a lot. But it's a changing thing. It's a very different attitude you take towards it. So that says that planning is adaptive. It's about understanding the consequences of change and making informed and controlled decisions about the change, instead of a predictive thing that says, this is how things ought to work out. And of course, that's part of what makes it hard to go down the Agile route. We would like it if things go according to plan. We like predictive planning. We hate it when most people tend to dislike things that are being unpredictable in this way. The Agile way of mindset, I think, is saying, well, yeah, it would be nice if we could do predictive plans. We would all love it that way. But sadly, reality forces us to work in a different mode entirely. But it's an easy thing to say, not necessarily an easy thing to do. And if that distinction is easy to say but hard to do, the second one, the shift to people first and process first, is an even stronger one. Now here, Linda spoiled my usual line, which is to say, who is this person? Who is this person?
Taylor.
Frederick Winslow Taylor. And as Linda said, he is the guy who came up with scientific management. Basically saying, you know, in the past before he started operating in the late 19th century, people would decide how to do work themselves. The man was first. But now we come up with a system and we make the system. Essentially, what it says that if we think about this in software process terms, We say, well, we define software process as some combination of steps and links between steps. Now, in the late 90s, you saw lots of diagrams like this, except there would be words, of course, in the boxes, but words usually didn't really mean that much. So I showed them without. And then say we've got a bunch of steps, and we find a bunch of people that are crudely classified into project managers, programmers, testers, business analysts, whatever your classification likes to be. And the way we form a project team is we get all the people and we fit them into those appropriate boxes. The notion is the process comes first, the people then just slot in and go with it. Now in the Agile mindset, completely reverses that. It says if you want to do a project in Agile terms, the first thing you think about is assembling a team of people who are individually good and work well together at a human level. That they get on with each other, as it were. And then, once you've assembled your team, the team decides what process they wish to follow. They come up with a process that's suitable for the problem they're working on and suitable for them. Different people will choose different ways of working because different people are different. And when people work together, they will work in different kinds of ways. And that's why, in my view, it's completely wrong to push and command a team to go agile. A team has to choose it themselves. If you're pushing the process of the team, that's fundamentally an un-agile idea. And so a lot of the time when I hear people saying, well, Agile says I've got to do this and therefore the team has to follow certain steps, that's where the thinking has gone backwards. The team has to decide what to try out. And if a team chooses not to do Agile, then that's because it's not going to work for them, that's fine too. It's important that the team makes that decision. Another element of this as well is that it says that in the end, the quality of the software team is going to depend very much upon the quality of the individuals in that team. A lot of the thinking in the plan-driven approach was to say, we actually don't care about having good people. In fact, good people are kind of awkward, so we'd rather not have them, because they tend to be argumentative and they want to do their own thing, and they cost a lot more. So we want to have a process that works for pretty much anybody. And part of the Agile thinking was to say, no, that doesn't necessarily work terribly well. And in fact, if you really want to have a very effective group of people, you need to have a team, you actually need to go out and get good people. And then those good people will want to work in a particular way, hence the need to have them define how the process works for them. And this, of course, lies, I think, well at the limits of when or where you should or shouldn't use Agile processes. In the early days, when people said, where are the boundaries of where Agile is an appropriate process to use, people might look at the kind of problem or the size of the team as being the typical boundary areas. And most of those boundaries have been crossed. But the one boundary that has been very, very solid really lays in the nature and culture of an organization. If you've got an environment that's very distrustful, that doesn't really, isn't interested in being people-oriented, that will be a hard barrier to making Agile work. It's that cultural element that really is the dominant one. And certainly we've seen that in part of organisations. We've spent a lot of time at Fowler helping people go the Agile path. And that is the clearest indication of where that kind of thing goes wrong. If you're in an organisation where you can't build up the trust and you can't build up the mutual respect, then that's a huge barrier to have to overcome. And cultural change of organisations is the longest and hardest thing to have to do. And that, I think, is the biggest barrier to Agile. But let's move on to the next part, which is this notion of fluency. I said this is a model that was developed by Diana Larson and James Shaw. It was one that I particularly liked when I saw it. And they said that fluency is really, as they look at the various teams that they've seen, they have observed what they defined as 4 star points of how the teams operate. They're very careful to avoid maturity levels and things of that kind in their arguments. I'll try not to use that word, although it kind of obviously leads to that point. Every team has to pass through these start points, but teams don't always make it all the way through, and it's often okay for them not to make it all the way through. So the first, not level as it were, the one start point, is typically a team that is getting the kind of basics of the management processes of Agile in place. They've broken down work into iterations. They have a certain degree of, some degree of self-organisation in the team. It may not be that strong. But the key thing is they're choosing work in small chunks, usually with some kind of iterative approach, and then delivering those individual chunks, and they have the ability to begin to shift direction. That adaptive planning thing is beginning to kick in, where they can actually change their minds, and they're starting to talk about what they're doing in terms of business features as opposed to software layers and things of that kind. So the great benefit of operating at this level is you have this visibility as to what the team is doing, even if you're not part of the team itself. You can begin to see what features are being built, what order they get built in, and you've got some ability to control that. You begin to say, I want to push this one feature forwards, push this one back. And when the team reports how well it's doing, it's typically doing that in terms of these kind of business value-driven features that are describing it. Now to get here, it requires, as any of these kinds does, a certain degree of investment. You've got to invest in how the team operates and how it develops, and also in kind of the basic work processes to get there. And it's going to take a certain amount of time. Their observation is to get to this point, teams usually take a few months to reach this kind of point. But a large amount of teams reach this level and in fact stay at this level. Their estimate was just under half of teams actually get this point. You could also look at this point as this is typical of a team that has taken on Scrum, and just vanilla Scrum, as it were. It's doing the various things that are described by Scrum, but it hasn't gone for some more extra things that you might want to build in particular, the technical practices. A team like this has the management side of Scrum sorted out, but not any of the technical things such as test-driven development or things of that kind. To go to that level, that is their second star level. And this is a harder step to do. Less teams get this far, and also it takes a good bit longer. We're talking perhaps about a couple of years at this point. And the investment is now much higher, because you've got to develop all of these technical skills. You've got to figure out what is continuous integration, what is continuous delivery, get those working. You've got to get refactoring straight, you've got to get test-driven development straight. You may want to explore things like pair programming and things of that kind. You've got to understand how evolutionary design works and be able to operate in that kind of way. But the benefit you get from it is, A, you get a much more productive team. More noticeably, you typically get a team with a lot less defects. This is one of the things that certainly strikes me very much when I talk to Agile teams. Often what I hear from reasonably well-performing teams on a technical level is how they go into production with far less defects than is typical for their organisation. And that's kind of an interesting thing, because it's something that people often say, oh well, Agile's kind of loosey-goosey and not very, and you would expect you get problems with quality. But actually a good performing Agile team will actually have strikingly lower defects. And that's because of the emphasis of things like test-driven development and these other technical practices. The shift that this leads from visible sense is that you get to the point where a team can effectively do their shipping, their delivering, not on whether the software is ready, but when business wants those shipments to make. This is what the phrase that they use is the market cadence. It's basically saying, we can go live whenever you want to, it's really now a business decision, not a technical limitation. And this is where you see teams shipping maybe every couple of weeks and going into production, or even more frequently. You quite often run into teams where they will commit to production every day or something of that kind. And that is because the technical practices and the quality has allowed them to get to the point where they can do this reliably. Now, I've described these two levels, and obviously the second level is somewhat superior to that first level, but not, as I've indicated, not every team gets to that second level, and perhaps not every team wants to try and get to that level. There is significant investment in getting to that second level. And you will typically pass through the first one before you get to the second one. But it's worth thinking when you begin, do I want to try and aim at that second level? Because you've got to make those kinds of investments on the technical practices early on. The third level in their model, this really switches more into the thinking of, this is where you begin to get into the lean startup kind of territory. That says at this point, up to the second level, you're very much receptive of what business people say, this is what we should be building. You have a good conversations, but you're very much more the receiver of ideas. Once you get to the third level, you begin to initiate them much more. The team is actually taking a much more active role in saying, this is what we should be building. And they're using techniques that come out of lean startups, such as A/B testing and things of that kind, to try and decide what the good thing is to do. But reaching this point is a lot more effort, both in amounts of time, as you can see there, several years, and very few teams actually get this far. And there's a large amount of investment involved because in order to do this, people within the team must be much more aware of what's going on in terms of the business. And they have to take a much more visible role in an organisation of the overall company. The first two levels you can kind of do within a relatively small bubble. It's really having a good software development engine is really what that second level says. This means taking it further out. It has a bigger impact on an organisation. So a lot of organisations are just not ready to go this third path. And often, I think it's important when working through Agile to decide, are you in an organisation that could really tolerably even do this third level? Are they ready to take this on? And most organisations, that answer is not going to be yes. They're going to say, no, we're not at a point where we could actually go for this point. But the advantage and the big benefit of this is that you get much more focus on building things that are more valuable, because the team is much more engaged in the process of making these kinds of decisions. Now the fourth level that I have is really a much more broader organisational view. This is, the test for this level is, this is a team that would spontaneously disband the project they're working on because they realise the entire program of work that they're doing isn't the most valuable thing for the business, and they should disband themselves and work on more profitable things. It's questionable whether this really ought to even be in there, because they say they haven't really seen this at this point. The comment in the paper is, where we've seen this, we've only seen this in small organisations where really you can't tell the difference between the third or the fourth level. So this is a somewhat speculative idea of where that next level might be. And that's why I'm not going to spend much time on it. But I think that model of thinking about Agile fluency is a useful one to think about. It's certainly something that seems to match a lot of people's experience in practice. As I've talked to people, a lot of people have said, yes, this model makes sense to me. It's something that I've seen, it resonates in my experience. And it also gives you an idea of where you might be or where you want to be going within the organisation that you're part of. What is a realistic level to aim at? What should be your expectations about how long it takes to get there? And I think it rams home the point that this is not a rapid process. In order to get even to a 2-star level, you're taking typically a couple of years for a team to actually get to that kind of point. It's not unusual to spend a lot of time getting there. And I think that's a useful thing to point out to a lot of people who like to feel that going Agile is really very straightforward. It usually isn't. Because that shift from saying we want our planning process not to be a predictive thing, but a much more adaptive thing, and we really are going to put people first and let them decide how they want to work, those are very big shifts. Shifts that organisations don't find easy. So that's all I have. I I guess there'll be some questions. I don't know whether there's much time for questions, but I'll let Ina decide that. And go from there.